shadow. You can see that it's close to reaching Iceland. We're about 5 minutes away from totality in Reykjavik. And over in Spain, you can see that we have about 45 minutes left until totality reaches them. So these are views from Villa Lobado in Spain that we're seeing right now. And if we switch back to the map, you'll see that the moon's shadow actually looks pretty slow as it's traveling across down towards Spain, but it's actually traveling at over 2,000 miles per hour. These maps will be capturing images and once totality hits Iceland. And on the right-hand side, we're seeing a partial eclipse from Norway, which is really exciting. So we have places across Europe that will be able to witness the partial solar eclipse. There will be many, many people here that will be able to experience this amazing celestial event. So we're about 6 minutes away from totality in Iceland. What do we expect to see right before totality? Right, so right before totality, we're in that partial eclipse that's going deeper and deeper, and you start to see things go dark. So even if there are clouds, it's going to get a little bit darker. The weather is going to drop too, because again, you blocked out some of the sunlight, so you're going to get cooler. There's some wind that'll pick up. So the eclipses are really full-body experiences. You might also notice that animals react as well. It's not just humans that experience this, but if there are any animals, they might start to pretend that it's nighttime or realize it's nighttime and start to kind of nest. And this is very unique for that part of the world, because right now they're on almost 24 hours of sun, so they are going to be a little shocked by this. And so you'll be experiencing a lot of different things, even if you don't get to see the beautiful corona. Yeah, I'm thinking about everyone on the ground in Iceland right now. They may be seeing clouds, but can you tell me, how does the climate shift when an eclipse happens? Because I've heard that the weather can change drastically.
Definitely. So from personal experience, in 2017, I was in South Carolina, and there were thunderstorms. And during totality, it parted just around the sun and was able to actually fully enjoy the eclipse and see my first total. That was my first total solar eclipse. So there is hope that the clouds are influenced by that change in day-night, that eclipse that's coming through. So we're hoping that some of the winds and some of the fast to get anywhere. That's something that we need to understand to be able to predict. It also affects our astronauts, our dear astronauts, and making sure that they're okay. So those things are really important to study, and one of the reasons why we have the WB-57. It's a little hard to see, but in the words on the right-hand side, you see that pink filament now on the WB-57 feed, which is on the right-hand side. And yeah, so you can see it in the NVIS area, now kind of right in the center. You're seeing that prominence, and so this is amazing data. And it might not look as crisp as we're used to. You know, we're used to 4K down here, but this is really data a scientist can love, because this is telling you can't see the corona itself, and a little bit looks like sunset around the 360 degrees. And you know, hopefully we'll see this in Spain, where it'll be very vivid imagery there.
Yeah, so it looks like totality has hit Iceland, which is so exciting. You can see that the ballooning team is engulfed by darkness here. So that is so exciting. I can see them smiling. Oh my goodness.
Which block the light from the sun's surface, allowing us to observe the corona
because there
far
is light
beyond
on
the
either side. It's just simply blocking out in that specific shadow. So it's like the sun has gone down
with
just in that one location, but you know, the rest of the earth is still illuminated. So you still have
for the first time.
oh wow, that is images of the sky
it is
and
not
the
a
airplane.
gentle
We're
outer
seeing the
glow,
airplane.
but a
Experiencing a partial. So
missions
in Iceland,
like
they are
Solar
experiencing
Orbiter are
totality
helping
right
us
now. We have
uncover its
experiments,
secrets every
balloons
single
capturing
day.
data in the skies, and also a plane
But
capturing data
it's
in the
still
skies
only
as well.
through total solar
We do.
eclipses
And it's really
that
interesting
we
looking
get
at the
a
sun.
rare
There are
glimpse of
some
the
features,
special
those
part of
lines
the
that you see,
sun
the dark
with
lines.
our own
Those
eye.
Let's learn more about their Eclipse project.
Images of the pole, which is really, really exciting. And we started to sort of see this really
Teams of students from across the United States have a unique vantage point of total solar eclipses, thanks to scientific balloons.
The nationwide eclipse ballooning project is a NASA mission-like adventure in collecting data from balloons that go high up into the atmosphere.
Started in 2014, the project engages college students and high schoolers in one of two distinct paths.
One is the engineering track that has mostly engineering students that get to tinker on different payloads. The other track is an atmospheric science track where they'll actually be launching weather sensors to study the impact of the eclipse.
Atmospheric science teams launch helium-filled weather balloons, the same as those used by the National Weather Service, every hour for hours before and after an eclipse. Engineering teams fly larger balloons laden with cameras and experiments they build themselves 100,000 feet up into the stratosphere. From there, they study a variety of things such as incoming cosmic radiation and ozone levels, as well as offering dramatic views of the moon's shadow on our planet.
The project is really a unique one in that it's both an education but also doing amazing science that's both about the eclipse itself and also the atmospheric response of the eclipse.
Student balloon teams made a historic first during the 2019 eclipse. They measured eclipse-driven atmospheric gravity waves in Earth's stratosphere, or large ripples in the air caused by the temporary cooling due to the drop in sunlight.
What excites me the most about this project is thinking about the experiences that the students have that they'll remember forever.
And this is called the boundary layer. But during nighttime, when the sun is down, this air stops, and it's called boundary layer collapse. So that's exactly the same thing that happens during the eclipse. And we're using these radiosondes to measure the atmospheric changes, the boundary layer collapse, and then the recovery. And we're in Iceland not just because it's in the path of totality, but also its northern latitude and its shorter nights make a completely different boundary layer. So it's been a really cool opportunity to be able to study that under the eclipse under this unique conditions.
So you're both college students right now. How long have you been part of the project, and what made you want to join the project?
Yeah, so we started this project at the beginning of June. So we've been working with our teams, respective teams, Tessa at the University of Kentucky, and then my team made up of students from across Idaho. And we've been meeting once a week, doing balloon launches, preparing.
levels of radiation
the general
during solar
theory of
storms.
relativity. For
Whether
centuries,
you're a pilot
our
or a
understanding
passenger,
of gravity was
a
built
farmer
on Isaac
or a
Newton's
consumer,
laws.
a power grid
They
operator
explained
or
why
energy
apples
customer,
fall,
a satellite
why the moon
controller
orbits the
or
Earth,
GPS user.
and why the planets
Space
circle
weather
the sun.
impacts
But
us all.
Einstein believed there was a deeper explanation. According to Newton,
if you're
gravity
just joining
is an
us,
invisible
welcome
force
to
that acts
NASA's
between
live coverage
objects,
of today's
no matter how
total
far
solar
apart they are.
eclipse.
But
We're roughly
Einstein
about
wondered,
24, 25
if
minutes
light
away
takes time to
from
travel
hopefully seeing the
across
first
space,
instance of
shouldn't
totality in
gravity
Spain.
take time
So
too?
stay tuned for that exciting
Einstein's
moment.
answer was
So
revolutionary.
joining me in the studio now is
Gravity
one of NASA's
isn't an
space weather
invisible
analyst,
force pulling
Karina Alden.
objects together.
Karina, thank you so much for joining me.
It's the shape
Thanks for having
of
me.
space and
So
time
your role
itself.
involves monitoring the sun in real time.
Imagine placing
Can you
a
talk a
heavy
little bit
ball
about
on
what
a
you do?
stretched sheet.
Yes, of course.
The
So
surface
what we do
bends
is
beneath
we
its weight.
basically observe,
Smaller
model,
objects naturally
analyze,
follow the curves
and
it
then
creates.
we document it.
In
And
much
so
the
what
same
we're
way,
observing is usually
Einstein
those coronal mass
suggested that the sun
ejections, or as I
warps
lovingly
the
like to
fabric
call
of
them, sunburps.
space-time,
And
guiding
we're
the motion
measuring
of
those, seeing where they
planets
go,
and even
then
light
we're modeling
itself.
them to see what NASA missions across
Einstein
the planets
predicted
they impact,
that light
and
from
then from
distant
there we're
stars
documenting
would
it and
bend
notifying
as it
NASA missions
passed
about
close to the
potential
sun.
impacts.
From Earth,
And so we just learned
that
a little bit
star
about
would
NASA's space
appear
weather
slightly
program.
out of position.
How does monitoring space weather
The
affect
would
the
be
everyday
tiny,
person?
And under
Yeah, so
normal circumstances,
most of the time the everyday person is going to see it in terms of northern
sun's
lights.
light
But
hides
what
the
we do
background
also
stars
see
from view.
is some of that impact to the
Only
GPS as
total
you're
solar
navigating.
eclipse
Sometimes
could
it'll be a little
reveal them.
wonky and you don't really
And
know
in
why, but that could
1919,
possibly be due to
that
some solar
opportunity
storming
arrived.
happening. And then we
British
may also see some
astronomer
impacts
Arthur
to
Eddington
agricultural
and his
folks
team
who are using
photographed
tractor
the
precision
stars
farming.
surrounding the eclipse sun
And so back in
Príncipe and
2024,
Brazil.
we saw these huge
just a few
solar
minutes,
storms. Can you
daylight
tell us how
gave
that
way
storm
to
affected
darkness.
Earth and if we had
After
to mitigate any of
carefully
those
analyzing
effects?
the photographs,
Yes, so along
the
with
astronomers
NOAA's Space Weather
found what
Prediction Center, we
Einstein
did
had
have to do some
predicted.
mitigation,
The
but
stars
honestly my
had
favorite
shifted.
part was seeing
Their
the northern
light had
lights.
been bent
And
by
so
the sun's
2024
gravity.
is when I first got to see the
The
northern
results
lights. I
made
saw them in
headlines
August.
around the world.
And then you're seeing a picture that I
Almost
took on my
overnight,
phone
Einstein became one
where
of
we
the
saw them
most
here in
famous
Maryland, which was
scientists in
absolutely
history.
incredible. And you can see a picture of the
Einstein's
team that I work
theory
with,
in the
Amanda Mars Space Weather
1919
Analysis
solar
Office,
eclipse
along with
was
some
just the
of the
beginning.
Heliocomms folks,
They
where we
transformed
got
our
to see it down
understanding
here in
of
Maryland, which
gravity
is
and
absolutely
laid the
incredible.
foundations for
Amazing.
modern
And so I
astronomy.
know that you're also part of the
They
team that
opened the door
monitored
to
space weather
discoveries
24/7
ranging from
during the
black
Artemis
holes
2
to
mission
gravitational
when we flew
waves,
astronauts around the
ripples
moon.
in space-time
What was
itself.
that experience like?
More than
Surreal.
a century later,
I
we're
mean,
planning
it's
to
very
study these
odd to
ripples
be
from
staring
space.
safely at the sun via satellite imagery, but not see it in person for an extended period of
you have it
time.
all here.
Because
Total
I was
solar
working the
eclipses,
overnights,
ripples
but it
in a
was
space-time
incredible,
continuum.
and I loved
And it's
seeing
all
the
about
solar
gravity.
eclipse from
And somebody
space. I
who's been
think
working on
if
the
I were to
detection
do
of
it, I'd want to be
gravitational waves
one of those
is Martin
astronauts.
Now,
Absolutely.
your current
Well,
role?
thank you so much for joining us, Karina.
Thank you.
On the LISA
So
mission, and I'm the
next,
performance
let's hear
manager,
from
so I
NASA
work in the
Administrator
project team
Jared
with the
Isaacman
team,
and Head of NASA Science
overseeing
Nikki
the building
Fox.
of the three
My
satellites
colleague
that
Jasmine
follow
Hopkins
the
caught up with them a
Earth.
few days ago to talk about why
Well,
this
first of all, let's
celestial
start with
event
the
is so
fundamentals.
important
What is a
and what the
gravitational wave?
2026 eclipse can teach us
So we
about
heard a
the
little
sun.
hint of that in the video that just played, but in
Today,
fact,
I'm
one of the
thrilled
other
to talk
predictions of
all things
Einstein's theory
Eclipse
was
with
that if you
NASA
accelerate
Administrator Jared
large
Isaacman, who's
masses
leading
in the
our
universe,
vision
for example,
behind
black
science and
holes,
why eclipses
then
are
these
so
will make
important,
ripples in
and Dr.
space-time
Nikki
which will
Fox
travel out
from our
the
Science
black
Mission
hole,
Directorate, who will tell
across
us
the
what
universe, and
exactly is
eventually
going on with the
arrive
sun
here at Earth,
during
where
an
we can
eclipse.
detect them with our
Are you guys ready to talk?
Absolutely.
Okay, fantastic. Our opening question is for both of you. Just a couple months ago, we wrapped up the historic Artemis 2 mission, and now we're on the cusp of a total solar eclipse. Can you describe in one word how you're feeling right now?
And there's a good reason to do
Excited.
that, because in fact,
He took my
similar
word.
to as we do for electromagnetic waves and for
Excited
observing
is the right word,
stars in the universe
because
in
when
different
you saw that
colour
total
bands
solar
using
eclipse
X-rays and
from
infrared,
Artemis
we can
2,
do the same thing with
it was
gravitational
so
waves.
spectacular,
And there we're looking at
and nobody
really
was ready
different
for it.
masses of systems.
Even people
Here,
who see total
with
solar
the LIGO
eclipses all the
observations
time.
that you mentioned in
And so when you
2015,
saw
we're
that, it
looking
just
at
brought the
objects,
beauty
merging
of
together,
space
which are
and the beauty of the
tens
science we do
times
into
the size
such
of our sun.
clarity.
Something
I think NASA is one of the only places where we can see a solar eclipse from down here on Earth and then from the other side of the moon.
We study the sun all the time. It's one of our main things that we study in NASA science. We look at it in all different wavelengths. We look at it from all different vantage points to be able to predict when these really large radiation storms are going to come towards our planet, because we want to make sure our astronauts as I say, the eclipse just gives us even more opportunity to study that sun just a little bit more to really make those big breakthroughs to keep our astronauts safe.
All right, next is for both of you. If you could witness a solar eclipse from anywhere on Earth, where would you choose?
Anywhere that doesn't have clouds. Having been clouded out for the last eclipse, I will say I will go anywhere that there's no clouds.
Look, Iceland is very cool. We spanned a lot of the observation locations for this one, but in Egypt, in the Valley of the Kings, is going to be an amazing backdrop.
And that is going to be the longest total solar eclipse of the 21st century. It is over 6 minutes. To stand in somewhere ancient is particularly moving.
Over these million kilometers.
What's the one thing you want people to walk away understanding about why studying eclipses matters?
I think these kind of magical events, I would very much describe that eclipse as a magical event. Maybe creates a spark, and who knows how many people around the world look up, imagine what's possible, and then grow up and start contributing
we know how to
this
do these
great
things. I
adventure
mean,
of our
there's a huge team of people across the world
Remember
working on
that
the
Einstein confirmed his theory of
quite a few
relativity
decades
using
now.
an eclipse.
So we can't see the light at the end of the tunnel yet, but we're definitely in the tunnel, and we are building the
Eclipses are very
satellites
powerful.
and
You see
getting ready
stars, you see
to
constellations,
exactly
you see
getting
planets
ready
that you
to
don't
launch
normally
these
see.
3 satellites.
It kind of reminds you of our place in the
about 9 years
universe.
from now.
Why do we still care so much about the sun? What is there even new
We have a lot to
worry
do
about?
in those 9
There's
years.
always new stuff to learn about the sun. It is our star, but it's the only star we know right now that has the responsibility for maintaining life on the planet. And as we sort of continue to try and answer the question of, are we alone in the universe? Understanding our relationship with our sun is so important. And eclipses give us that opportunity to do that. It is honestly the only time that we can really observe some of the phenomena, particularly down low in the chromosphere, really looking at how the corona turns into the solar wind. It bathes all of the planets, but we live in the atmosphere of the sun, so when you get these big events, they can cause havoc for technology here, and of course, our prime thing, keeping our astronauts safe in space. So understanding our sun is
In those kind of sepia tones instead of the normal bright light or even the normal types of sunsets.
Wow, so we are 2 minutes away from totality in Spain. You can see the crowds in the bottom corner there, and this is the sun's view. Oh my goodness, so 2 minutes.
and seeing just one bite out of the moon, the whole body experience, and just the joy and awe and kind of your place in the world is so important to experience.
Absolutely. For sure now an eclipse chaser. Well, that was an incredible solar eclipse. What a view. I am thrilled that their skies were completely clear, which means that we could see the sun's corona so clearly. And we could even see multiple prominences as well from the sun, which is a beautiful sight during the eclipse. So in a few minutes, we're going to be speaking with a NASA astronaut live from where they saw a total eclipse. But first, let's go back to the poll that we posed to you earlier on in the show. So, Kelly, I know that you had answered some of those questions as well. So let's take a look at what our viewers thought about those questions. Okay, so
amazing, and thank you
let's head to one of the poll questions. But while we're kind of like waiting to get that set up, let's continue looking at this beautiful partial eclipse now in Mallorca, Spain.
That's just gorgeous.
Yes, but
that is just absolutely gorgeous in terms of that very little sliver. Again, this is towards sunset. So normally if you're looking at a sunset, especially over water, you're seeing that kind of orange ball, red ball go down, and then you have this beautiful eclipse to happen. These really are just going to be spectacular images.
Yes, absolutely. Okay, so let's head back to the poll answers. Our viewers, so the first question was, where would you rather watch an eclipse from? You said the International Space Station, and our viewers would agree.
Yes, it'll be a party on the International Space Station.
I also wanted to be there too, so we weren't sure what we would have. The second question on the poll for everyone watching was, what would be your ideal eclipse watching soundtrack? And the options were cosmic lo-fi beats, dramatic space opera music, chill acoustic sky watching vibes, or just the sounds of nature and the crowds. And the winner was cosmic lo-fi beats.
So yes, I hope you were able to share
that's a good soundtrack. I can see that.
I voted for opera music, but
and I might be a little bit more sound of nature, but
a cosmic coincidence.
Well,
but the sun and the
anyway,
moon,
thank you so much. So although totality is over, the partial eclipse will still be visible for the next hour or so. Remember to stay safe while watching the rest of the partial eclipse by wearing eclipse glasses or by using an interactive viewing method. And so if you want to learn more about eclipse safety, go to science.nasa.gov/eclipses. Okay, so next we have a very special guest calling into the show live. NASA astronaut Don Pettit just witnessed the total solar eclipse from Alcaniz, Spain. Don, can you hear me? How are you doing?
I can hear you loud and clear, and I'm standing out in Alcaniz, Spain, just in awe from looking at the totality phase of this eclipse.
Wow, so how are you feeling? I know you just finished watching the eclipse. How are you feeling right now? What did you experience on the ground, and what did you hear? Were you surrounded by crowds at all?
The sky is exceptionally clear, and there's hundreds of people here, and that's part of the eclipse. It's not being off by yourself, it's being with a group of people, the people that live in Alcaniz, the group of people that I'm here with, and experiencing this amazing celestial event all together.
Amazing. So people might know you for your incredible photos and videos from your multiple trips to the International Space Station. Did you take any photos during this eclipse, or did you put your camera down for this one?
Oh, no, what I do is the same thing for launches. You set a camera up on automatic, and you get whatever you get from the camera, and then you stand back and you watch the launch, or you watch the total eclipse. They're both kind of in the same category, and they only last a couple minutes in terms of what you can see, and it's better to view them through your own two eyes than through the viewfinder on a camera.
Okay, good tip from a NASA astronaut. So how did the experience watching this from the ground compare to watching an eclipse from space, which I know you've done a few times?
I've had the opportunity to see two solar eclipses from space, and in space you look at the shadow projected on Earth. You don't look at the sun itself, and the shadow has all the detail that the classic astronomers from hundreds of years ago predicted. You see the umbra, you see the penumbra, you see the shadow moving over Earth, and it's a vantage point from space that you can't see from Earth.
Wow. So lucky. And I know you've seen a lot of other beautiful phenomena in space, like the aurora and air glow. What is it that makes watching a total eclipse special for you?
It's the whole package that comes with a total eclipse. It's the shadow phenomena that happens around you. It's looking at the corona around the sun. It's experiencing the reaction of all the people you're watching it with. So it's a human emotional event as well as much physics and natural phenomenology as you want to add to the mix.
Wow. Well, thank you so much, John. Any parting words?
Just get out and watch an eclipse, whether it's a total eclipse or a partial eclipse. They happen. Lunar eclipses happen. Get out and look up at the sky and think about what's going on and smile.
Thank you so much for joining us live from Spain. We're so grateful you can share
Un mundo
your
más Pepe es
absolutely amazing
ofrecerte cada vez
experience with
más
us.
por menos.
You all take care.
Más información en
Wow, Kelly, it's
pepefon.com.
amazing to hear someone
Pepefon.
as passionate and
¿Qué
knowledgeable as John.
pasa, familia? ¿Cómo
Yes,
estamos? Bienvenidos un día.